completion, and vision is sealing excellence in electrical perfection. Hello everyone, good day. Once again, this is Professor Roger Flores of the Department of Electrical Engineering, Associate Professor of Central Mindanao University, your Professor of the subject E41, Electrical Circuits 1. And for today, we are going to continue our discussion with this chapter 10, the last chapter of our subject. It is entitled Fundamentals of Inductors. Here we are going to discuss some information and definition of terms, units of the inductors, the characteristics of these inductors, no? The function of the inductor in any circuits. Okay, so this is our topic, fundamentals of inductors. Okay, so to start with, we have these contents. Start with an introduction, terms and definitions, and symbols and units, magnetic field, and we have this electricity and magnetism, inductance, no? So we have this the inductance, the type of inductance. Okay, so we have here inductors in a circuit or inductors in circuit. Then we have the last topic here is the energy storage, no? The energy storage. So as for introduction, in many ways, the inductor is the dual of the capacitor. And chapter 9, we discussed capacitor. And we said that capacitor stores energy. And the capacitor also will help to supply our circuit for a short instance. No? So similarly, this inductor is also will also stores energy. And of course, it will also induce voltage and apply also current, no, in an application of a current, or vice versa, no. So in other words, either the supply is voltage, then you are going to induce or flow. There is a flow of electric current, and then or our source is a current, and it will induce voltage to our circuit. Okay. Then, like the capacitor, the inductor exhibits its true characteristics, no? And when a change in a voltage or current is made in the network. So, in other words, kapag mayroon tayong change ng value ng voltahe natin or current, then there will be a corresponding induced voltage or current respectively. Okay, so we have this now. Then for the terms and definitions, we have here the inductor. It is a device which is usually a coil, a turn of wires, no, a magnetic wire, number of turns of the magnetic wire that introduces inductance into an electrical circuit. Later on, we will define the inductance, no? So we have here, no, the property of an electric circuit when varying current induces an electromotive force in that circuit or another circuit. So it is either we are going to induce voltage if we have this electric current supplied, okay, to the circuit, or towards another circuit. So the induction of the voltage is not only limited to a single circuit, but it could be also induced in another circuit. Okay, so we have that inductance. We have another word defined here. We have the self-inductance. No, it is the property of an electric circuit when an AMF or electromotive force is induced back into itself. Okay, back into itself. In other words, there is a self-induced AMF. No, so we have that. No, by a change of circuit current. So, in other words, in every time we have a change of electric current, there is what we call as induced voltage due to this inductance. Okay, so the unit of the inductance is Henry as we know it, no? Okay, so we have here, we have another words to define. We have this permeability. So what is this permeability? This is the measure of the ease with which material will pass lines of flux. So in other words, this permeability is the measure of the easiness of this flux. By the way, this flux ay ito po yung sinasabi natin minsan na magnetic line of force. Ito po yung fluxes, no? So magnetic line of force or magnetic field. So okay, so ganyan. So ito po yung tinatawag natin minsan na flux. So do not be confused with that, no? Magnetic line of force, magnetic field, fluxes, pares-parehas lang po 'yon. Isa lang po 'yon, no? So, permeability is the measure of easiness or easement with which material will pass lines of fluxes. Okay. So we have meron po din tayong tinatawag na kanina meron po tayong sinabing self-inductance. Here we have also this mutual inductance, no? This is of course the property of two circuits. Dalawang circuits na po ito. At saka yung EMF na ma-induce natin, yung electromotive force na ma-induce natin in one circuit is by a change of current in another circuit. Okay, so mayroon tayong dalawang circuits. Tsaka if this circuit 1 will have its own current source. Okay, if this current source will change, okay, there will be an induced voltage to another circuit. Okay, so ito po yung ang dahilan po dito, ito po yung tinatawag natin na mutual inductance. Yung inductance galing sa isang circuit towards the other circuit or vice versa. Okay. We have also this word coupling coefficient. It is a number indicating the fraction of flux lines of one circuit cutting another circuit. So we have that coupling coefficient. So number of flux from this circuit which is coupled with or to another circuit. So we have that what we call as coupling coefficient. Okay, so I think we are familiar, no? Some of us or all of us may be familiar about transformer. So basically our transformer is a device that will transform voltage, no, or current. Okay, transform voltage to current. Most of the time, it will step up the voltage or step down the voltage or step up the current or step down the current. So, yun po ang purpose ng transformer. So, as we defined here, it is a device that transfer a changing current and voltage from one circuit to another through inductive coupling. So, mayroon po tayong tinatawag na inductive coupling. In other words, this induced or inductive meaning there is no direct connection between these two circuit. So ito pong sinasabi nating circuit, halimbawa dito sa transformer, ito po yung sinasabi natin na primary at saka yung secondary circuit. So iyon po ang minsan na maririnig natin sa transformer, step up or step down. So it is either to step up the voltage or step down the voltage, or it is either step up the current or step down the current. Okay, so we have to discuss also some of the symbols and units. Okay, the symbol of the inductance is L, and of course as we mentioned a while ago, the unit of this inductance ay ito pong Henry po, having a symbol of small letter h. Okay, so any rate of current or change of current per unit time, we have this di dt or the differential of current per unit time. Okay, per differential of this time. So mayroon po tayong tinawag dito na mutual inductance, so L sub M, or sometimes yung ginagamit natin na letter po dito is just simply capital letter M. We have that inductance. Of course, the unit of this mutual inductance is also Henry, no? So the mutual inductance, the self-inductance, they have the same unit. We have that in Henry. So we have, mayroon po tayo dito tinatawag na coefficient of coupling, that is constant letter K. So minsan po ito pong tinatawag natin na proportionality constant. Yan po yung letter K. So mayroon po dito tayong mayroon po tayong sinabi dito electromotive force. Yun po ang EMF, no? So that is the precise word that you are going to use as the voltage or the potential difference in the source side, no? So it is measured in volts. So we have that in volts. Then we have also this permeability as we defined while ago. We have the symbol mu. Okay, a Greek letter mu. So as to remember, it is the capacity or the property of the conductor for the easiness, or so that the flow of this magnetic field is easy to flow. No, so we have that permeability. It is just a measure. Okay, so let us start with the magnetic field. Okay, this magnetic field sometimes represented by concentric magnetic flux lines. Okay, so concentric flux lines. Pag sinabi nating concentric, that is para bang circular, no? Flux lines, so magnetic flux lines. Circular po yan. Okay, present around every wire that carries an electric current. Okay, so consider this conductor. So example lang, mayroon po tayong conductor ng, ito pong conductor nito, ito po, conductor, no? So, if this conductor, mayroon po itong kuryente, mayroon po itong current na nagfo-flow at this direction, no? In this direction, so mayroon pong concentric magnetic flux na mag-rotate, okay, na mag-rotate around this conductor. Okay, so ito po yung tinatawag natin na concentric magnetic flux line. Okay, so ibig sabihin, pag mayroon tayong conductor na current carrying conductor, this current carrying conductor will produce its magnetic field along, okay, perpendicular. The direction is perpendicular to the axis of this conductor. Okay, so the direction of the magnetic flux, okay, so the direction of the magnetic flux lines can be found simply by placing the thumb of the right hand in the direction of the conventional current flow and noting the direction of the fingers. Okay, so it's very easy. Okay, so we have this one. Halimbawa, ito po yung conductor natin, at saka if this is your conductor, mayroon pong magpo-flow na kuryente at in this direction, okay, going to this direction. Okay, so ganito pong gagawin natin. Use your right hand, okay? Ito pong tinatawag natin na right hand rule. Okay, use your right hand. Your thumb will follow the direction of the current, okay? Going to that direction. Your thumb will follow the direction of the current. And these fingers will follow the direction of your magnetic field. Okay, so parang ganon, no? Parang ganon po yung direction niya. So ito po yung ulit yung tinatawag natin na right hand rule, no? So this is the direction of the current, this is the direction of your magnetic field. Okay, so that is the direction of your magnetic field. So that is just a conventional direction because therefore whatever the direction of our current, we will determine the direction of our magnetic field, okay, by using our right hand rule. But of course, take note that it is just conventional because basically nobody can see an electron or the current flow. Okay, so we have this simple illustration, no, defining the flux density. So ano po itong flux density? Mayroon po tayong conductor. Ito po, conductor natin na shaded by a blue color. Okay, so this is your conductor. This is the cross-sectional area represented by capital letter A. That is the cross-sectional area. This arrow here, ito po mga arrow na ito po yung mga fluxes natin. Okay, it is represented by a Greek letter phi. Okay, so yung flux density natin, ito po yung measure of your fluxes, your phi, inside this cross-sectional area. Okay, So ito po yung tinatawag natin na density, flux density for the given cross-sectional area with the given number of fluxes in that cross-sectional area. Okay, so that is your flux density V. Okay, so ito po yung flux distribution for two adjacent magnetic or magnets, no? But take note, they have the same or like poles. So mayroon po tayong isa po dito, ito po yung magnet, tsaka yung isang end dito is north and the other end is also north. So pares-parehas lang po yun. So the direction of your fluxes will be this direction. Okay? So what will happen to this, because we have these like poles, so pag ganito po ito, yung mga fluxes natin, it will tend to repel each other, no? So walang mangyayaring attraction because they have like poles, they are like poles. So ang mangyayari dito, ito tulak natin ito, yung magkabilaan, magtutulakan, kasi po like poles po yon dahil dito sa ito pong mga flux lines. Okay, so this is another illustration of the determining the direction of the flux for an electromagnet. So ito po yung una, yung ito po yung sabi natin kanina na right hand rule, no, right hand rule. So we have that direction of the flux. Okay, we have this direction of the current direction. Okay. So ito po ang ang illustration niya. So halimbawa, ito pong mayroong parang period dito sa ilalim. Ito po yung parang tip ng yung arrow natin, at saka yung sa kabila sa ibabaw, yung parang mayroong mga X diyan sa ibabaw. Ito po yung makikita sana na parang yung sa likod ng arrow, no, nung sa pana, no. So parang ganito 'yan, no, para makita natin ito. Dito sa ibabaw, parang yung likod ang makikita natin, at saka yung dito sa ilalim, yung tip ang yung makikita natin, no. Going to me, no, going to me. So dito sa ibabaw, going to you, and then dito sa ilalim, going to me. Kasi po tip yung makikita ko dito sa ilalim. Okay, so parang gano'n na po ang yung pag to determine the direction of your magnetic field. Okay, so we have this the unit of this unit of the magnetic flux, no? So mayroon po tayo unit ng magnetic flux. Ito po yung ang unit niya is Webers po. So ito po yung Webers, no? Derived from the name of Wilhelm Edward Weber. So that is we have the symbol letter V. Okay, so we have also, punta lang po ako sa kabila. Okay. So mayroon din po tayong tinatawag na flux density, sabi ko po kanina, and that is the product of the area. Okay, the area and the number of fluxes, no? The cross-sectional area times the fluxes. Ito po yung conversion niya. By the way, the unit of that flux density is Tesla. So it is in honor of the contribution of Nikola Tesla when it comes to generation, no? Malaki po siyang contribution diyan. So we have that 1 Tesla or 1 capital letter T is equal to 1 Weber per square meter. Okay, so that is your flux density. So we have this okay, so the flux density, okay, so of an electromagnet is directly related to the number of turns number of turns of the coil and the current through it, no. So ibig sabihin, kung para malaman natin kung gaano kalaki yung flux density natin, then we need to have the amount of the current that will flow towards that current and the number of turns of that current. So that is why we have this formula of the electromotive force, which is of course synonymous to hindi pala electromotive force. We have this magnetomotive force. It is synonymous to electromotive force, okay? So this magnetomotive force is the force produced due to this current that will flow to this conductor with respect to the number of turns. So we have that magnetomotive force. Okay, so as I've said a while ago, that is synonymous to electromagnetic or electromotive force. Okay, so the unit of this magnetomotive force, we have this formula, no? So we have this formula, parang F, tsaka it is the product of the number of turns and the current. So the unit here is ampere-turns. Okay, so we have this magnetomotive force, which is equal to the number of turns times the amount of the current, and your unit is ampere-turns. Okay, so this is the picture of our device that will measure the magnetic field. It is called the milli-Gauss meter. Okay, milli-Gauss meter. Of course, it is called milli because it will measure a very small amount of this magnetic field. Okay, so let's continue with this electricity and magnetism. So here we will be able to discuss the relationship between electricity and the magnetism. Okay, so ano po ang kinalaman ng magnetism diyan sa production ng electrical energy? Okay, so we have this inductance comes from the magnetic field around any conductor that carries current. Ito po yung tinatawag natin na current carrying conductor. This means that electricity and magnetism are related. Okay, because if we have this current that will flow in a certain conductor, it will produce inductance, and this inductance will be the cause, or will be the ito po yung dahilan na mayroon po tayong tinatawag na magnetic field around this current carrying conductor. There are two laws linking electricity and magnetism. Yung una po ay yung Ørsted law. So Ørsted's law. Okay, so anyway, we will discuss this one by one, and the other one is Faraday's law. Okay, so tinatawag po natin tong Faraday's law of induction. It was discovered in 1831. Okay, so we have this Ørsted's law. So unang-una, ito po ay na-discover po, ito pong law ay pinoformulate ni Hans Christian Ørsted. Okay, he is a Danish physicist, no? And he noticed that when a compass was located near a wire with current flow in that wire, the compass needle will align perpendicular to the wire. Okay, ito po yung observation ni Ørsted, no? So halimbawa, ito po yung itong green is ito sa taas. Ito pong green, ito po yung conductor natin. Mayroon pong nagfo-flow na kuryente represented by this arrow I, certain this blue color. So if the direction of the I is going here, no? Ito po, saan po ba to? Okay, so we have this one, no? Papunta po dito. So in this direction, so mayroon po itong mapoproduce na magnetic field perpendicular to this conductor. Ito pong green. Okay. The direction is something like that, no? Something like that. So ito po, mayroon naman po itong arrow sa ibabaw, no? So tignan nyo na lang po. Ito po, kung titignan nyo po, ito po yung conductor na mayroong kuryente, nagpo-flow, mayroong mapoproduce dito na magnetic field in this direction. We have this flux density B. So here, the Ørsted concluded, according to Ørsted, that any current flowing through a conductor creates a magnetic field around the conductor. So I should have to emphasize that this magnetic field is not in this hindi po ito ito po sa conductor, ito sa taas, hindi po. Ito po ay andyan sa surface perpendicular to that conductor. Okay, meron po ibang mga detalye po ito dito sa Ørsted law. Magnetic field lines, meron po yung magnetic field lines. Encircle the current carrying wire, and we have that current carrying wire, and then the line in a plane or lie in a plane perpendicular to the wire. So yun po ang magnetic field. Okay, lines. So if the direction of the current is reversed, the direction of the magnetic field also reverses. So take note, kung ano pong mangyayari sa kuryente natin, then iyon po din po mangyayari sa ating magnetic field. If current reverses its direction, your magnetic field also reverses its direction. Okay, the strength of the field is directly proportional to the magnitude of the current. Okay, ibig sabihin, pag malaki yung kuryente natin, nagpo-flow diyan sa conductor natin, ang ating magnetic field is higher din po yung strength niya, or bigger yung strength niya. At any point is inversely proportional to the distance of the point from the wire. Ibig sabihin, pag ito po yung conductor natin, mayroon po itong kuryente, mayroon po itong mapoproduce na magnetic field. Okay, so the amount of this magnetic field as going apart, no? Papalayo itong point, no? Papalayo po itong point. Okay, ito po yung conductor natin. Tsaka dito sa malapitan, malaki po yung magnetic field, or yung strength na magnetic field. Okay? So, habang papalayo ito, mas lumiliit. Okay? Because they are inversely proportional. So, ibig sabihin, the strength of the magnetic field nearer to this current carrying conductor is greater compared to the strength of the magnetic field away from this conductor. So, yun po ang ibig sabihin dito, na the strength of the field at any point is inversely proportional to the distance of the point from the wire. Now, let's talk about Faraday's law, or the law formulated by Michael Faraday. So, according to Michael Faraday, and he found out that there is a transient current produced in a coil when a bar magnet was quickly moved in and out of the coil. Okay, so consider this is a coil. Okay, this is a coil. So ito pong coil, madali po nating maalala natin yan. Kasi para po itong spring, no? Parang spring. Okay, ganon. So we have this coil, and yung number ng turns will depend on the magnetomotive force, yung sinabi natin kanina. Okay? So if mayroon po tayong coil ng ganito, paglagyan natin ng magnet dito sa loob, okay? Mayroon tayong magnet na ipapasok dito sa loob. Ano pong mangyari dito? Sabi po dito, mayroon po daw magnet, or there is it will produce a current, no? Okay, there is an electricity in short na ma-induce dito sa ating winding. Okay? So, mayroon tayong winding dito, mayroon papasok dito na magnet, then habang ito pong magnet natin ay i-move natin in and out, then there is what we call as mayroon po tayong mapoproduce na kuryente, or tinatawag po natin na transient current na mapoproduce dito sa dito sa conductor turns ng ating conductor. Okay, so the faster he move, meaning the faster Michael Faraday moved the magnet, the more current was produced. Okay, so klaro ito, no? So ibig sabihin, ito pong magnet, pag if there is no motion between these turns of conductor coil and this magnet, kung wala po itong motion, ay wala pong mangyayari, no? So kailangan mayroong motion, itong magnet natin, papasok natin in and out, there is an induced current here in this coil, or in this turned of conductors. Okay, similarly, when a conductor cuts through a magnetic field, a voltage is induced into that conductor. So, kanina, ito pong magnet ang pinapasok natin. Ngayon, halimbawa, if ito na namang conductor ang igagalaw natin, mayroong ma-induce na kurente or voltage dito sa conductor na gumagalaw. Okay, so ito po yung sabi dito. That the conductor cuts a magnetic field, a voltage is induced into this conductor. If the conductor creates a complete circuit, current will flow in that circuit. So, anong ibig sabihin? Halimbawa, siguro we are familiar sa ito pong sinasabi natin na magnets. Yung magnets natin, minsan, ito pong natural magnet. Ito po karamihan makikita natin sa mga speaker ng sound system, no? Mayroong magnets, okay. So halimbawa, mayroon tayong dalawang magnet. Okay, ito po tinatawag natin na pole phase, no? Ito po pole phase po ito, dalawa. So let us consider that ito po ay north, ito po south. So ibig sabihin, mayroon po tayong imaginary magnetic line of force, okay? Okay, magnetic line of force dito sa between ng dalawang pole phase, no? So north saka south. Okay. So halimbawa, pag mayroon na tayong magnetic field dito, tsaka lagyan natin ng mayroon tayong isang conductor na i-move natin, stationary itong dalawa, i-move natin up and down, okay? Up and down. Ito po is an example of a conductor. Ito po up and down, up and down. So para po bang ang mangyari daw dito, parang ito pong mga magnetic field or yung mga fluxes natin ay parang mga rubber band, no? Rubber band, yung lastiko, parang lastiko nga po. So, pag i-move natin itong conductor dito i-expose natin sa magnetic field, parang rubber band, mapuputol daw yung mga magnetic field dito or mga fluxes. Mapuputol. Kasi po, mayroong napuputol dito na mga magnetic field, mayroon daw ma-induce na voltahe dito sa conductor na nagputol ng mga magnetic field. Okay, so I hope that ma-imagine po ninyo. So, ito po yung observation ni Michael Faraday. Kaya nga, mayroon tayong tinatawag na induced voltage dito po sa mga conductor na nakakat ng mga magnetic flux. Okay, so this magnetic or Faraday's law states that the electricity comes from the magnetism. So ito po, yun po ang contribution ni Michael Faraday. That the electricity comes from or produced due to this magnetism. Simple lang po. Just remember, cutting of fluxes, cutting of magnetic flux, there is an induced voltage. Saan po na-induce ang voltahe? Diyan, o later on, generate yung gagamitin natin na term. Saan po ma-generate yung voltahe? Dito po sa conductor na nag-cut ng magnetic line of force or fluxes. The induced electromotive force in any closed circuit is equal to the negative of the time rate of change of the magnetic flux through the circuit. Okay, so sinabi natin kanina, pag mayroon tayong magnetic, mayroon po tayong conductor at saka we have this current carrying conductor, mayroon po tayong mapoproduce na magnetic flux. Okay. Pag mag-reverse po itong kurente, halimbawa, for a certain instant going here, another instant pabalik, then there is a change of the direction of the magnetic field. So, for this change of the direction of the magnetic field, there is what we call as an induced voltage. Saan po may induce? Dito po sa surface. Okay? There is, because of the reversal of the direction of the current, the magnetic flux around this current carrying conductor also reverses. So, because of this reversal, there is what we call as cutting of fluxes. Theoretically, cutting of fluxes. Now, there is what we call as induced voltage dito po sa surface. And this induced voltage is opposite to the voltage, okay, dito po sa ating current carrying conductor. Opposite po yan. So para bang mangyayari diyan, mamaya sasabihin natin na parang magiging voltage drop yan. Okay, so gaano kalaki? We have this formula. We have this the differential phi or the flux density with respect to time. So d phi over dt. So bakit po negative po ito? Kasi it is opposite. Okay? Ito pong sinabi ko po kanina na yung voltahe na ma-generate dito sa surface is in opposite to the voltage na dito sa ating conductor. Okay, so ayan po, dahil opposite yan, so that is why it is minus. Okay, so we have this, the negative sign is just because the changing magnetic field induces a voltage back into itself in any way that opposes the original change in current. Okay, so changing magnetic field, ibig sabihin, ga-change po yung direction niya ng ating magnetic field. Paano mag-change ng direction ng magnetic field? I-change natin ang direction ng ating kuryente. Okay. So that is why kapag hindi nag-change ng direction yung kuryente natin, di walang ma-generate, walang mapoproduce o ma-induce na voltahe o kuryente sa surface natin. Okay po. Yun po ang ano. So ibig sabihin, pag ang kuryente natin, pag ang current carrying conductor, ang kuryente ng ating conductor dito is direct current, isa lang po yung direction niya. So walang ma-induce na voltahe dito sa surface. I hope na that's clear. Because that induced voltage in the surface is due to the changing current or the changing magnetic field. Okay, so if there is another conductor nearby, the changing magnetic field will also induce voltage into this other circuit. Okay, so ito po i-discuss natin yan mamaya. So we have these details of Faraday's law. Okay, steady current produces steady magnetic field. Okay, only a time varying magnetic field creates an induction. Okay, so time varying magnetic field. Pag walang nagbabari, walang ma-induce na kuryente o voltahe kaya. The observable phenomenon here depends only on the relative motion of the conductor and the magnetic or the magnet. So ito po yung sabi ni Einstein. Okay. So ibig sabihin, if there is the relative motion between the conductor and the magnet, there is what we call as this observable phenomenon, which is the induction of the voltage. This relative motion can be because the conductor is moving. Okay. So, dalawang sitwasyon po tayo. Yung una, yung conductor yung nagmo-move. Yung una, yung kanina lang is yung magnet natin ang nagmo-move. Okay? Yung pumapasok, labas-pasok na magnet. Yun po yung nagmo-move ang magnet. So, dalawang instance yan or dalawang situation yan. Okay, so the effects is summarized by Lenz's law. Ano po ba itong si Lenz's law? Okay, a changing current through a circuit that contains inductance induces a proportional voltage with which opposes the change in current. So ito po yung pag sinatawag natin na itself sa ito po change ng kuryente dito sa the current carrying conductor due to the induced voltage or induced current. Ito po yung tinatawag natin na self due to the self-inductance. Self lang po yon. Okay, so the induced voltage is called CEMF or counter electromotive force. Counter. Okay, so yun po yung mapoproduce natin na or ma-induce natin na voltahe dito po sa surface. Okay, varying field in this circuit may also induce an electromotive force in neighboring circuit. Ito po ang tinatawag natin na due to mutual inductance. So, ibig sabihin, mayroon tayong na-produce na mga magnetic field dito. Pag aabot ito sa kabilang circuit, mayroon tayong another circuit or another wire or another coil. Pag aabot itong magnetic field nito, ito po mag-generate din doon sa kabilang circuit dahil po sa magnetic field natin. So, yun po ang tinatawag natin na dahil po sa mutual inductance. The inductance from this circuit towards this another circuit. So, mayroon po din po tayong tinatawag na induced voltage or induced current in the other circuit. That is because of this tinatawag natin na mutual inductance. Okay, so this Lenz's law describes how the induced electricity or magnetism acts compares to the originating electricity or magnetism. Okay, so ito po si Lenz, ito pong Lenz law ay nagdi-describe doon sa napoproduce natin na electricity or magnetism because of this movement, because of this scenario. Okay, compared to the original electricity, voltage, or magnetism in the current carrying conductor. Okay, so one important result of Lenz's law applies to a generator. So we will know later that this generator is a machine that converts mechanical energy to electrical energy. Therefore, from this mechanical energy input, it will have an output of an electrical energy. Okay, so ito po ang mangyayari. Okay. Therefore, the more electrical energy a generator delivers, the more mechanical energy is required to turn it. Okay. So, we need to a greater value of this mechanical energy if we need to produce more electrical energy. So, let's discuss about inductance to be more specific. Okay, this inductance is a property that allows, property of the inductor or conductor that allows conversion of one form of energy into another form. Okay, when we say one form of energy, it could be mechanical energy converted to electrical energy. It could be a solar energy converted to anyway, wala namang mangyari pala doon. Okay. So from solar energy to electrical energy. From energy from steam or ito pong sa steam turbine from steam okay, heat energy then converted to electrical energy. From chemical energy to electrical energy. Saan po ba tayo makakita ng chemical energy? Doon po sa mga battery, yung sa mga automotive battery, yung mayroon pong mga battery solution, parang ganon. So that is a chemical converted to electrical. So, yan po yung inductance. It is a property that allows conversion from one form of energy to another form of energy. So, electric energy into magnetic energy. Isa na po yon. Magnetic energy into electrical energy. Vice versa, in other words. Okay, conversion only happens when the initial value is changing. Okay, so ito po, palagi natin sinasabi kanina pa po na mayroon po tayong sinasabi natin na changing current, changing voltage so that there is a conversion of voltage and current respectively. Okay, this means that inductance acts differently for AC versus DC. Because DC never changes its direction. Okay, it will change the magnitude but it will not change the direction. Wala pong ibang mag-change dyan. Ang problema natin ngayon, baka wala din po itong induced voltage or induced energy to the other circuit. Okay, inductor offers a resistance to AC. An inductor, okay, so we have this, an inductor offers no resistance to DC. Okay, so walang resistance, walang internal resistance sa isang inductor po. Okay, so that is if it is an ideal, no? Okay, so inductance is often described by this formula. Okay, makita niyo po dito, mayroon po tayong instantaneous voltage in terms of time. It is equal to the inductance times the differential current per unit time. So we have this di dt, no? The inductance times di dt, the differential current in terms of in terms of time, no? So 1 Henry is ito po yung generalization natin sa inductance po. 1 Henry is the amount of inductance required to generate 1 volt of induced voltage when the current is changing at the rate of 1 ampere per second. Ito po yung rate of change of our current per unit time, no? So 1 ampere per unit second or per unit time. So we need to that we have this 1 Henry of inductance. Okay, so that we will have to generate 1 volt of voltage or potential difference or EMF. So type of inductance, we have this. We have the self and or simply inductance. No, that is self-inductance. It is the property of a circuit whereby a change in current causes a change in voltage in the same circuit. The same circuit, that is self-inductance. Pag sinabi natin mutual, ito po ay change in current to nearby circuit. Okay, so we have this dIdt is read to us as the rate of change of current per unit time. Okay, you have this V sub t is the voltage at particular instant of time, also called electromotive force. Okay, so we have this derivative here of the dIdt. So we have this di per unit time or with respect to time. Okay, your d here is a derivative okay, from that formula. Okay, so we have this, ano po ito, dito po, mayroon itong tinatawag na opposing a change in current. When voltage is increased in circuit with inductance, some of the electrical energy goes into increasing the magnetic field, which means does it not increase immediately. Current does not increase immediately. So ano po mangyayari po dito, pag malaki, pag lagyan natin ng malaking voltahe yung circuit natin, it will produce more magnetic field, and this magnetic field, because the current is changing, it will induce a voltage at the surface, and this voltage of surface opposing to the originating voltage, then mayroon po tayong counter EMF, then it will reduce. Okay, so lalong liliit yung voltahe natin. When voltage is decreased in a circuit with inductance, the magnetic field of the inductor starts to collapse, returning to electrical energy to the circuit and maintaining current. Okay, so it will release voltage, it will release energy from this inductor. Okay, so these effects are temporary, and it is time based. Okay, so we have this formula of inductance in a coil. So mayroon po tayong N po dito. So dito po, we have this N, this is the number of turns. Okay, mayroon this inductance varies directly with the square of the number of turns. And mayroon po tayong mu sub O. Ito po, so tinatawag natin po itong permeability of a core. This mu sub O will based on the relative permeability of the conductor. Okay, mamaya mayroon po tayong tinatawag na relative permeability. And this permeability, mu sub O is the permeability of a conductor or a core. Therefore, ito pong permeability ng conductor ay specific, okay, or permanent for a given core. So anong klaseng core po ito, or anong klaseng metal material na metal, mayroon itong equivalent permeability, and that is constant for that specific core. Okay, so mayroon po tayong tinatawag dito na cross-sectional area. Ito po. So this capital letter A. So ito pong cross-sectional area ng core. Inductance varies directly proportional, no? So the inductance as the cross-sectional area becomes greater or bigger, lumalaki din po yung inductance natin. Okay? So because they are directly proportional. Yan po. So mayroon po din tayong tinatawag dito na length or L. Ito po sa ilalim, ang denominator po natin. Ito po yung length ng core. Okay, so inductance varies inversely proportional. So mas lalong tumataas yung core natin or tumaas yung core natin, ay the inductance will become smaller because they are inversely proportional. So ito po yung formula for Henry or the inductance natin. So you have this differential phi or flux per unit current. So ito po yung flux natin, ito pong mapoproduce natin po dito, mayroon po ito pong tinatawag natin na counter EMF. Okay, ito po yung voltahe na na-produce natin, na-induce natin dito sa atong surface natin. Tsaka this is with respect to time or dIdt, the rate of change of our current and with respect to time. So 1 Henry of inductance, ito po yung conclusion natin, yung generalization natin. 1 Henry of inductance is present when an ampere of an ampere change of in current per second causes counter electromotive force of 1 volt. Ito po yung generalization natin. Okay, so the Henry is relatively large unit, and most inductors are measured in millihenries. Okay, so or sometimes it is microhenries. Okay, so ano po itong millihenry? This is negative 3. So 10 times 1 times 10 to negative 3. Ito pong microhenry is 1 times 10 to negative 6. Okay, ito po. So we have these types of inductors. Ito po yung tinatawag natin na air core na conductor. Bakit tinatawag po itong air core? Kasi po ito para pong spring. Okay, parang spring. So pag spring, wala dito sa loob, sa gitna po dito, bakante po ito, bakante. So kasi po ito bakante, consider natin yung core natin is air, hangin lang po. So ito yung example na tinatawag natin na air core na inductor. Ito po yung variable inductors, no? Variable inductors. Kapag titingnan nito, ito pong pula po dito is a winding. Okay, ay winding. Ito pong pula. Tsaka pag ginagalaw mo po itong itim dito sa ilalim, it will move downward here or upward. Okay? So pag mag-move na po itong winding natin, it will change the inductance of this winding here of our core or our coil. So ito po yung symbol natin. We have this okay, ito po symbol natin ng inductance. Mayroon po tayong diagonal arrow. So ibig sabihin variable po itong inductance natin. Ito po yung fixed to fixed na mayroon po tayong fixed inductor dito, inductance dito. Ito po tinatawag natin na magnetic or iron core. Okay, so ito pong dito sa loob, ito po circular iron po ito or material, a core, no? Metal po ito. So para po itong donut, no? So mayroon po tayong winding dito. Iniwon natin itong conductor natin along this parang donut na core. So ito po yung tinatawag natin na iron core sa gitna, no? Sa loob. So ito po yung symbol natin. Ito po yung symbol natin na gagamitin natin later on sa tinatawag natin na transformer. Okay? Kasi po yung transformer mayroon din yung iron core sa loob. Okay, isa pa to na isang example ng inductor, malaking inductor. Ito po yung tinatawag natin na roller inductor kasi malaki to . Okay, so makikita niyo dito para siyang spring pero sa gitna mayroon itong core sa loob. Okay? So if you're going to change the distance between this parang spring dito, ito masyadong malapit, ito sa kabilang dulo medyo malayo, iba ang inductance dito compared sa dito sa mga malalapit na mga winding. Okay? So this is a sort of a variable inductor, but it is called the roller inductor. Another example here ng inductor, ito pong tinatawag natin na lopstick inductor. Kasi po, mubabol itong core natin sa loob. Okay? Mubabol itong core natin sa loob. Okay. Ano bang gagamitin na to para mag-move ito? Ito, mayroon tayong adjustment rod dito. Pag i-rotate natin ito, siguro papasok dito sa loob ng coil, sa ilalim ng coil natin. So, it will change the inductance of this coil. Okay? So, ang ganitong nangyayari, yung core natin sa loob, ito po yung pinagalaw natin o i-change natin. Okay? Papasok natin yan, palabas, pasok, palabas. Okay, so the inductance of this inductor or coil here will change due to this change of the core inside. Okay, so this tubular form na lopstick inductor. Okay, so ito po yung example na yung core ang nagmo-move, no? Nagmo-move. Okay, so yun po ang isa pang type of adjustable lopstick inductor. So dito po ngayon we will discuss the inductors in a circuit. ano po yung mangyayari pag yung inductor natin, yung inductors natin, halimbawa more than 2 no, or 2 or more. Halimbawa mayroon tayong tatlo na inductors, no. Ano mangyayari pag i-connect natin to in series? So ganito po 'yan. If you're going to determine the inductance of a series connected inductors, just take the sum of these inductances. Okay? So, tatlo. So, ibig sabihin, mayroon tayong L1, L2, L3, inductance 1, inductance 2, inductance 3, so on and so forth. To determine the total inductance, then just to take the total or the sum up the individual inductances. Ayan po. So, series inductance is additive, similar to resistors in series. Yan na po. If you can still recall capacitance, baligtad po yon. Ang series na capacitor parang parallel na resistor. Okay, pero dito sa inductance, ang resistor o resistance saka disinductance, pare-pareho po yung formula. Okay, so ayan na po. That is the series formula assumes no magnetic coupling between inductors. So ayan, we assume that walang influence, no other influences. Walang other influences yung circuit natin kasi malayo siguro yung mga walang nearer circuit. Okay, so ayan na po, walang effect ng mga mutual natin. Okay, so as an example, we have this circuit, no, tatlong inductors, L1, L2, and L3. Yung inductor 1 mayroong 8 henries. Ang inductor 2 mayroong 10. Ang inductor 3 we have this 22 henry. So if you're going to take the total, as we said, just sum up, then we have more or less 40 henry. So as simple as that. Ito po yung inductors when they are connected in parallel. Ano po mangyayari? Para po itong resistance na o resistors na nakakonect ng parallel. So your total inductance is just equal to the reciprocal of the sum of the individual reciprocals of the individual inductances. Ito po. So if you have these two inductors connected in parallel, then you have the total inductance is equal to L1 times L2 divided by L1 plus L2. So basically similar to what we did in our resistors. That is, if we have two resistors connected, two inductors connected in parallel. Okay. Pero kung mayroon po tayong equal, no? Unequal po 'yan. So, halimbawa kung mayroon tayong equal, so katulad sa ginagawa natin sa resistance, then divide the inductance by the number of the inductors connected in parallel. 'Yun lang po pag they are equal, no? Parehas-parehas din po doon sa resistance. So, formulas assume no magnetic coupling between again. Total inductance is less than smallest parallel branch. Okay, the inductance of the connected parallel in a branch. So, yun na po, pares-pares lang po, sabit po kanina. Mayroon po tayong example dito. So, we have this circuit, L1, L2, L3, and they are connected in parallel. So, we have the L1 is 10, we have L2 is 15, L3 is 30 Henry. So, okay, so ito po yung solution natin to solve for the total inductances. Okay, so more or less we have 5 henries of these inductances. Okay, so we have this is the general equations of your inductances, no? So if it is in series, the equivalent inductance is the summation of LS or L sub S, no? Kung ilan po yung inductor natin, ito po. I-add natin din lahat. Pero yung sa parallel combination, then we have this summation of 1 over LF. Now, F is equal to 1 to F. Then that is, we have this inverse. So, this is reciprocal. Okay? So, ito na po ang matrix differences of the series parallel or a combination of series parallel of the capacitor, the inductor, and at the same time the resistor. No? So, yun po. Okay, so yun po ang differences ng series, ng capacitor, resistor, and inductor. More or less, as we said, parehas yung resistor at saka inductor, saka baligtad yung sa capacitor po natin. Okay, sa series parallel. So, just review with that. Okay, so let's continue our discussion with this stored energy. So, sabi po natin, the flow of energy to the inductor creates a magnetic field. Na ganito po yung mangyayari, no? Mayroon po tayong magnetic field dito sa loob ng spring natin. Kung ano po yung direction ng current natin, mayroon, it will produce the using this right hand rule. Okay, minsan nga magkamali tayo kasi nag-hand right rule tayo, pero yung ginagamit natin ay itong sa kaliwa natin ng kamay, no. So yun nga ang kadalasan na mangyayari na mali yung direction natin kasi itong kaliwa yung ginagamit natin. Okay, so if the current flowing through an inductor drops, the magnetic field will also decrease and the energy is released through the generation of electric current. So pag mag-drop ito pong kuryente natin or the current flow will drop, then what will happen to the magnetic field dito sa surface ay magda-drop din. So magre-release din doon ang na-store natin na energy. So saan po ba ma-store yung energy? Dito po sa magnetic field. Okay? Dito po sa magnetic field. Dito po sa loob yung stored energy. Okay, so stores energy in a magnetic field. Ito po, sinabi na po niya dito po. Created by the electric current flowing through it. Okay. So inductors opposes change in current flowing through it. Current through an inductor is continuous. Voltage can be discontinuous. Okay, pwede putol-putol po yung voltahe natin, pero yung kuryente natin kailangan continuous yan. Okay. So, basically ang yung conductor natin ay in a real sense, no, in a real situation, ang inductor natin ay mayroon po itong ano po tawag ito, property ng capacitance at the same time mayroon po itong property ng resistance. That is for a real inductors, no. So pero kung i-consider natin na ideal, so walang resistance, walang capacitance, so inductance, purely inductance lang po yon. Pero sa actual po, sa ito po sa realidad, sa reality, mayroon po itong tatlo. In the presence of resistance, presence of capacitance for this inductance. Okay, so more or less we finished discussing the an introduction to these inductors, no? So this is the last topic. Anyway, in a higher electrical subjects, you will know more about these inductances. Magsasama-sama na po itong tatlo, the inductance, the capacitance, and the resistance. So thank you for listening, and I hope that you learned something with regards to the with regards to our discussion about these fundamentals of inductors. So once again, ulitin ko po na kung mayroon po kayong na or if you learn something, please subscribe my YouTube channel and then likes and share so that paki-subscribe para more or less pag mayroon po akong i-upload na bagong mga video sa mga discussions natin, then you will be notified. Okay, God bless, thank you, and keep safe and keep healthy. Thank you very much and good day to everyone.
We are one in mission and vision is stealing excellence in electrical profession. Heavy power, professional association.